This is chapter 2, section 1, about power and radical functions. So power functions, when you are dealing with power functions, you might be given some negative exponents. If you're given negative exponents, you should rewrite them to get rid, because you can't have them. That's like one of those rules. It's not allowed. No negative exponents. So to turn an exponent negative or positive, to change the sign of it, you move it across the fraction from numerator to denominator or denominator to numerator. Just switch. So the 3 is in the numerator. Since there's no fraction here, that means the 3 is in the numerator and it will stay there. The x is to the negative 2 power. So if we want that to be the positive 2 power, we're going to move it to the denominator. So we would rewrite a negative exponent as a positive exponent by moving it across the fraction bar, whichever way. And then, so you might be given negative exponents and need to rewrite those, or you might be given a rational exponent. If you're given a rational exponent and you have a problem like this one where it says graph and analyze, f of x equals x to the 5/2 power, you might need to rewrite it into radical form. So the power is on top and the root is on the bottom. So the way I remember that is like a flower. It's kind of a cheesy example, but it works. And you have roots on the bottom of a flower. So remembering which number goes where, roots are on the bottom. So if 5 is the flower, the power is the flower, and the root is the root, roots are on the bottom. So we know the 2 is the root and the 5 is the power. So I could rewrite this as the square root of x to the 5th power, right? Or I could also take the power and put it on the outside, like parentheses square root x, and then raise it to the 5th power afterwards. So these are both, all 3 of these are equal. They're all the same thing, just written different ways. I chose to use the square root of x and then raise it to the 5th power afterwards, because if I'm going to graph by hand where I get a table, I don't want to take my x value and raise it to the 5th power first, because then I'm going to have a really big number to work with, and then take the square root of that. Well, I don't know my square root of 256 off the top of my head, but if I did it this way and I did the square root first and then raise it to the 5th power, I have a lot smaller numbers, easier numbers to work with. So I chose to use this one. You choose which version of radical form that you want to, based on the problem that you have. All right, so this again says graph and analyze. So first I rewrote it so that I can graph it. I am going to graph without a graphing calculator. Yes, you have them. I'm not planning on taking them away. But you should also know how to do this, a basic sketch of a graph without a graphing calculator. Like maybe SAT, like tomorrow's SAT day. There's going to be a math portion where you don't have a graphing calculator. That's probably the ones that they would ask the questions on, that you need one. So if I'm talking about a square root function, I know what that parent function looks like. It starts at 0 and goes to the right, to the positive numbers. We don't take square root of a negative number because that would be imaginary. So that tells me if I'm going to choose my x values, I could start at 0. That would be a good number to choose. And if x is 0 and I plug it into y equals the square root of x and raise it to the 5th power, y is equal to the function when I plug in the x value. So if I take x as 0, square root of 0 is 0, 0 to the 5th power, it's 0 times 0 times 0 times 0 times 0. That's 0. So I found my y value by choosing whatever x value I wanted. And then I can plot that point, 0, 0. I'm going to pick another x value. I need at least 3 to get a decent graph. So I'm going to pick another x value. I've already eliminated that. I don't want to use negative numbers because those would be imaginary. So I'm going to go with 1. When x is 1, what is y? So I take x as 1 and I plug it in here to my function. Square root of 1 is 1. And then 1 to the 5th power, 1 times 1 times 1 times 1 is 1. So that means I have a point here, 1, 1. And this is why I need 3 points, because there's a lot of graphs that have those 2 points, but they end up looking very different. So that's not enough information. I need at least one more. So, okay, what about 2? Well, if I did square root of 2, well, I don't know what the square root of 2 is. So I don't want to use that number. So then I try 3. If I plug in 3 is square root of 3. I don't know square root of 3. I don't want to use that number. What if I use 4? That works. Well, so if x is 4, square root of 4 is 2. And then 2 to the 5th power is 2 times 2 times 2 times 2 times 2. That's 32. So that gives me a y value. So when x is 4, now 32 is going to be way up there, but I know at least kind of what it's going to look like. And it's going to be like kind of like that, going up towards 32. I could also graph this in my graphing calculator and look at it that way. It says graph and analyze. So I graphed it. For the analyze part, when you do your homework problems, these are the items that you should be listing. Whenever for the analyze part, we need the domain of f. Well, I know it's a square root function to the 5th power. I see my graph starts at 0 and goes to the right. So my domain includes 0, and it goes to infinity. So the value's on the x-axis. And then range. Range is the y-axis, so I start at the bottom and I go up. Again, it starts at 0 and then it goes up to infinity. So the range is also bracket 0 to infinity. I need to list any x's and y intercepts. If there's more than one, list more than one. Since I have a sketched graph, I can easily tell that the x-intercept is 0, 0. The y-intercept is 0, 0. So that's the only place this graph touches the x or the y-axis is at 0, 0. End behavior. So what's happening on the end? The right end. So as I go, x's get bigger, the y's are also going up towards infinity. I'm going to write it different than I've written it in the past. The way I taught you was limit as x goes to infinity of f of x equals infinity is the way that I have been showing you. That is the proper way of writing a limit notation. So as you go into calculus or any other class, this is the way everybody does their end behavior notation. For your semester exam, though, the district has done it a little different, and it's more of a simplified version, so I'm okay with you practicing using that and recognizing what that looks like. It's going to be as x goes to infinity, comma, y is going to go to infinity. So these are saying the same thing, but on your semester exam, it's going to look like this one. So I just want you to get used to seeing that now, so it's not a surprise in December for the test. So this is semester exam notation.
Are we going to get exempt from that exam?
No.
Wait, what?
You can only be exempt from the spring semester exam, not the fall. All right, so then the next question is asking, is this graph continuous? If it's not continuous, then you should name any points of discontinuity. So we can tell by looking at the graph, it doesn't look like there's any breaks or anything going on, any gaps in this graph. So we look at the equation. There's no denominator, so there's no vertical asymptote. We know it just goes from 0 to infinity, so no. This is continuous. It's continuous along its entire domain. So it's continuous from the interval of 0 to infinity. And then the last thing for the analyze section would be name any intervals where the function is increasing or decreasing. All right, so we look again from 0 to infinity. It's going up as a positive average rate of change. So that means it's increasing the entire time. But we do not use brackets when we talk about increasing and decreasing behavior. It's not increasing at 0. 0 is where it starts, and then once it begins, then it increases. So parentheses 0 to infinity. All right, so that is the first section of notes where we're talking about switching between exponential form and radical form, which we did right here also, and graph and analyze. So for the second part, dealing with radical functions and solving, you may be given a problem in exponential form, and you could turn it into radical form to solve it this way, if you need to. All right, so I gave you the problem. Yes, p as in like power over n for nth root. So the nth root raised to the p power. You can use whatever letters you want. That's just what I have here. All right, so now for solving this equation, we have a radical equation. If we want to solve for x, there's an x under the radical. So first thing we have to do is get rid of the radical so that we can solve it. And in order to do that, we need to get it by itself. We need to isolate the radical. There's a -2 on the outside, so we'll just add the 2 to the other side, and then it's gone on the right side. And on the left, now we have 2x plus 2 is equal to the square root of 100 minus 12x. And putting this little tail on the end of your radical can be very useful, so you know what this -2 is not underneath it, and things don't blend together as you go through the 100 steps that you go through on some of these problems. All right, so now I have the radical is isolated. Square root is by itself on the right-hand side, so if I want to get rid of the square root, I'm going to square it. If I square the right-hand side, I'm going to square the left-hand side. So the entire left side, so I have to put it in parentheses and square the parentheses. So the purpose of this was so that the square root and the squared will cancel. So now on the right-hand side, I have 100 minus 12x. And on the left, I have the parentheses squared. So I'm going to have 2x plus 2 times 2x plus 2. I'm squaring the binomial. All right, so when you to square a binomial, I use the FOIL method. If you want to stick with a different method that you know, that's fine. But this is the one I'm going to go through. I'm going to FOIL. So I'm going to multiply the first term of each. First,
outside, inside, last.
First, outside, inside, last. Yes. So 2x times 2x gives me 4x squared. Outside is 2x times 2, so plus 4x. Inside, 2 times 2x, so 4x again. And then last, I have 2 times 2, so that's plus 4. And you'll notice that as you square a binomial, you'll end up with a repeating part in the middle every time. So I also have equals 100 minus 12x. Then I can combine the like terms in the middle. So this is 4x squared plus 8x plus 4 equals 100 minus 12x. All right, so now it's looking a lot more familiar, quadratic, because it's x squared, but I need my quadratic equal to 0. So to make it equal to 0, I'm going to take everything on the right, move it over to the left. I have a positive 100 on the right, so I'm going to subtract 100 on the right and subtract the 100 on the left from the 4 because that's its like piece. And I'm also going to get rid of the 12x. It's negative 12x, so I'm going to add 12x. And so I'll add the 12x to the 8x. So now on the right-hand side, everything is gone, and it's just 0. On the left, now I have 4x squared plus 20x minus 96.
The GCF will be 4.
Mm-hmm.
And
So-
it's going to be x squared plus 5x minus 54.
Yes. So then now that I have my trinomial on the left, look for a GCF if you have a GCF, which 4 is the GCF. All right, so we have factor out of 4. Greatest common factor is 4, and that leaves x squared plus 5x minus 24 equals 0.
Wait, how, you just did the,
The greatest common factor. I divided all 3 of them by 4, pulled the 4 out front. It is a factor, but it's not going to get us to their solution. We're trying to solve it, so we need to finish factoring what's in the parentheses. So we're going to leave the 4, and then I'm going to factor what's in parentheses. You can factor it with whichever method you use. I use the ACB method. When the lead coefficient, when the a value is 1, it's the real easy factoring that I don't need to worry about dividing by a, because when you divide by a, it's dividing by 1. So I go ahead and just split it into my 2 sets of parentheses. I have x squared, so I split up my x's, x.
X plus 8.
Whenever the second sign is negative, that tells me one of these is going to be positive and one of these is going to be negative.
Does it matter or no?
And since I'm multiplying to a negative, I needed one positive, one negative. But I'm going to add to equal a positive. So if I add to equal positive, that tells me my larger number needs to be the positive one.
8.
Yes. So the factors that multiply to 24 and add to 5, it's going to be 8 and 3. So the larger one is the 8. The smaller one is the 3. So positive 8 times negative 3 gives me negative 24. Positive 8 minus 3 gives me positive 5. So that works. All right. So I'm factored.
Lost.
And then I want to solve. So I'm going to take each factor, set it equal to 0, and solve. But this 4, the greatest common factor, does not have an x in it. So there's nothing to solve. If I said 4 equals 0, there's nothing to solve. There's no x in there. So that is not part of my solution. It's just a factor. So I'm going to take my factors that have variables in them. So x plus 8 equals 0. So x equals negative 8. And x minus 3 equal to 0, so x equals 3. And that's my 2 solutions. So you would think you would be done, but you're not done, because this was a radical equation. If you have an nth root that is even, then you have to check for extraneous solutions. This is a 2, so it's the square root. So you have to check for extraneous solutions. All right, so you're almost done, but you have to make sure these both work. So I'm going to take x equals 3, and I'm going to check to see if it works. To check it, I go back to my original problem, but I'm going to write it with blanks for all my x's. So 2 times blank equals the square root of 100 minus 12 times blank minus 2. And I'm going to plug in when x is 3. So fill in the blanks with a 3. Solve the left side and the right side and see what happens. So I have 2 times 3, that's 6. On the right side, there's a lot there, so I just type that in the calculator. As long as you type it in correctly, it should be fine. And it tells me 6 equals 6. Yes, 6 equals 6. That's true. So x equals 3 is a solution. So yes, x equals 3 works. Then I want to check my other one. X equals negative 8. Same thing. 2 blank equals square root of 100 minus 12 times blank, and then minus 2 on the outside. Fill in a negative 8. So on the left side, I have negative 16. And then I type all this on the right side carefully into my calculator, and I get 12. Negative 16 equals 12. No. Negative 16 does not equal 12. So negative 8 is not a solution. It is an extraneous solution. So I have to say that. It's an extraneous solution. So even though it's an extraneous solution, it is still part of the answer. It's a solution. It's in the name, extraneous solution. So you can't just solve it and only give me the 3. You have to give me both of them and just tell me that one of them is extraneous and the other one is not. And you have to show that you checked also. Okay, I'm going to stop this.